looks like. The blue represents anything that you as students have worked to deduce and find, and the red represents our margin notes or our takeaways or the things that we are adding on as we come together. So I would suggest getting out like a pen or a pen of a different color. I have a couple red pens if someone would like one. I'd like one. Anyone else? Yep. A couple of these are new, so just check that there's like a little, sometimes there's like a little ball cap to come off. Okay, this is a sample, but let's debrief on our own. Okay, problem 8 asks you, what is the color of the hypotenuse of your triangle? What'd you get, group 1? Yellow. Okay, group 2, what'd you get for 8? Group 3? Did you get there yet? Group 4?
Yellow.
Yellow. Okay, the yellows have it. Sorry, I'm looking for mine. Yellow, absolutely. The yellows have it. Group 1. What answer did you get for 9? What color is the light that is not connected to your angle? Purple? Purple. How about 10? Light attached to your angle. Only one option, right? Red? Red. So, respective to the angle, the yellow is your opposite side. And respective to your angle, the red is the adjacent side. Anything in red we are adding on. And these ratios, before you come back together to complete problems 10 and 11, these ratios have sides. The ratio of the purple over the yellow is your sine. Purple over the yellow, your sine, that is your opposite.
What do you mean like that?
Let me show you a great example. I would add that in towards this middle chart. In fact, I can even, here, I'll come back to that in a second, okay? Your opposite over your hypotenuse. The red was, which side, Salome? Yep. Adjacent, red is adjacent. Adjacent. And that yellow remains the hypotenuse. We have a name for the ratio of adjacent over hypotenuse. It is the cosine. Your question? Oh, trouble with the pen. And purple over red. I think I heard it. Tangent, tangent. Opposite over adjacent forms our tangents in any side respective to, remember this is about perspective, this is about our reference angle. It's relative. Red is adjacent to this angle. However, if we were referring to this acute angle, red would be the opposite. It's all relative. Okay, and then let me flash back to that margin notes. Too far. I'm going to give you 2 minutes to copy this down. And then I'll give you about 3 minutes to discuss with your partner. Blue is what you should have. Red is what we're adding on. Red is takeaways. Okay, once we wrap up these margin notes, I would like you to get back together with your teammate or your partner to complete problems 11 and 12, and we will debrief that as well before we fill in the quick notes and check for understanding. Yeah. Yeah.
Oh, that's not right. That's not right. They're all good. That's not good.
It's the same thing. I'll put the same thing. I'll just print out data, not this
Okay. In reference to our group chart,
Did you finish writing that?
I'll post the answer key if there's something you missed. What about, you're right. What about comparison between groups 3 and 4? What do you notice?
They're both in the two.
Problem 11. Let's come back together to just to keep things moving. Problem 11 asks us to look at the class data recorded on the board. Which groups had similar triangles, and how do we know? Group 4, what do we think? Which groups had similar triangles? Okay, Sarah says groups 3 and 4. I agree with you. I agree with you. Sarah says groups 3 and 4. 3 and 4, okay.
Also, I didn't know.
Ditto. I'm putting a ditto from group 1. That came 3 and 4 from group 3. I just said ditto. Ditto. I'm just reflecting the voices in the classroom. Group 2. What did we notice? What did we notice? Which of the 4 had similar triangles?
Same one.
Okay.
I
Same
don't
ones.
know.
And how'd you know? How'd you know? Folks who said that groups 3 and 4 had similar triangles, what was similar? What numbers were similar?
Abstraction. For your testing.
The decimals, okay. Group 1, anything else to add to that? Their lengths. Okay. What about their angles? Okay. Yeah. So good conclusions here. Let me layer in some information. What we should have seen, and there are some, minor inaccuracies in measurements. What we should have seen is that groups 1 and 2 had similar triangles, as well as groups 3 and 4. They had what we would have hoped to see. And in groups 3 and 4, we have very, very similar ratios. Angles, not quite, but that's okay. And in groups 1 and 2, we have pretty similar angles, not as close in the ratios department. So we had a unit error, but it's okay. It's okay because we're just here to make these takeaways. So triangles with same angles and same in ratios, let's think back to our previous unit. These triangles are, they're not congruent, but they are. Our last unit was on what? Headline start with an S. Similarity, absolutely. When we have triangles with the same angles and the same ratios, we have similar triangles. Same size and same perspective, same ratio, same proportions, but not the exact same size or they would be congruent. Okay. Before we check for understanding, please copy down into your quick notes. Top of page 2, these are our big takeaways for the day. Each ratio of sides in a right triangle has a specific name and its value is determined by the angle measured. Given a right triangle with a reference angle, there's a specific name for the ratio of the side opposite to the angle in comparison to the hypotenuse. There's a specific, and that specific name is the sine. There is a name for the ratio of the side adjacent to the angle in comparison to the hypotenuse. That is the cosine. And lastly, there is a ratio for the opposite over adjacent sides in reference to the angle. Depends where you're standing, depends where you're measuring from. That is the tangent. Our mnemonic device for remembering this, SOHCAHTOA. Sine, opposite over adjacent. Cosine, adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. Oh, does that kind of like oval with the line through it? That's a reference to the angle. I think it's,
Why can't you still
this symbol comes into play when we discuss trigonometry. I think it's a Greek symbol. Let me try to deduce it. Again, remember I told you trigonometry is an entire course unto itself, and we're just biting off a chunk of it here in geometry. But let me try to answer that question. Okay. Couple of you asked what this was, if it was a 0 or something else. This is the Greek symbol theta, and it is commonly used, the internet tells me, it is commonly used to denote an unknown angle within a triangle. So yeah, you have the right idea. When we say like sine of this angle, this is a new standard. I refreshed my memory today. Okay, we are down to a handful of minutes left in class, about 5 minutes left in class. Could you please get back together with your partner and to close out the day, complete our check for understanding. You will complete problems. Nope. Complete problems 1, 2, and 4 only. 1, 2, and 4 only. That's all I got for you. I do have some homework some review problems to leave you with, but this is all we'll complete. problems 1, 2, and 4 under check for understanding into the tray when complete. Yeah,
Can I turn in the homework that I was doing for next one?
absolutely.
Okay, thanks.
Sorry. Not just what we did know then, or is it something else? Yes. So it is. Oh. Nothing.
That was 5 minutes.
So this was just a repeat. Okay, are you done?
Yes, 5.
Yes. Thanks.
Is that ice cream truck? That was a tomato. No, that's a tomato. It's all right, it's not on the floor. Okay. Okay.
You do the opposite.
I don't.
I thought it was 6 or It is. Is mine wrong or not?
Yeah. Oh, of course. We're- okay, so let's find our theta, our reference angle. So let's start at our reference angle. Tangent is going to be which of our ratios? Which comparison? Opposite over adjacent. Okay, so with the tangent of this, the opposite side would be what measure?
No idea. Oh, I'm shifting there.
2?
I mean-
And the adjacent measure would be what? 3? Okay, that's a tangent of 2 over 3. If the opposite over adjacent is 2 over 3, that fulfills one of our, yeah. Okay. Yep, so opposite is, adjacent is that 2 over 3? No, would it simplify to 2 over 3? No. My first clue in was the top number was bigger than the bottom number. So no, no, so that's no. Opposite, adjacent, opposite, adjacent. Yeah. Yes,
You got 6 over 10.
you don't have a pen.
Is this great?
Opposite over, opposite, sin of h, opposite over hypotenuse. So what you gave me is, you gave me for this sign, I think I see opposite over adjacent. So opposite's in the right place, but let's compare to, yes.
Are these right?
Let's see, cosine of h. Cosine of h, first measure I'm looking for is adjacent, 12, good. Hypotenuse, 13, good. All right, tangent, I'm looking for, first measure should be opposite over adjacent. Okay, good on the rest.
And are these,
Give me a second, we're kind of running short on time here. Folks, with just about a minute left in class, could you please turn in your worksheets, your classwork of the day, whatever you got, I'll take it just into the tray, and then please make sure you make note of our homework before we leave. or that you plan to check Google Classroom for those review problems.
But I tell you that
Sure, sure. Yeah, I'll take it.